Welcome, my friends. Come on in, pull up a chair, and get comfortable. Just imagine I'm pouring you a fresh, warm cup of mint tea right now. Let's have a really good, grounded conversation today. In this explainer, we're embarking on a journey to find your exact place in the honorable pursuit of technical knowledge. Whether you're a student trying to map out your major, or maybe you're a professional looking to pivot. Understanding the actual architecture of modern technical fields, well, it's absolutely the very first step to building a deeply meaningful career. Okay, let's just dive right into this with a fundamental question. Do you want to discover the secrets of the universe, or do you want to build it? Look, I know it sounds incredibly simple, almost like a riddle, right? But this question cuts straight through all that career confusion we all face. Literally, every technical career branches off from how you answer the single profound question. Are you driven purely by uncovering the hidden truths of nature, or are you driven by using those exact truths to forge something tangible, something that actively elevates and serves your community? Well, to answer that, we really need a map. So let's trace our path across what we call the Stem Continuum. I want you to think of these disciplines as interconnected gears in the great big machine of human civilization. We start at the absolute root with abstract logic, which is pure mathematics. Then we move into understanding nature, which is science. That knowledge then flows outward into building solutions, which is the heart of STEM and engineering. And finally, if those solutions are actually going to reach the masses, they have to be scaled, and that requires leading organizations or business. Let's pause for some brotherly advice here, a bit of a reality check. We so often group science and STEM together in one big bucket, don't we? But they actually have profoundly distinct souls. Science is the relentless pursuit of the why. It seeks foundational, absolute truth about the natural world, completely regardless of whether that truth is actually useful to us right now. STEM, on the other hand, specifically technology and engineering, that is the how. It focuses intently on applying that discovered truth to build safe, practical, and affordable solutions that actively serve, heal, and protect our communities. Let's start at the very beginning of our continuum, mathematics. The divide within math itself actually perfectly illustrates this entire journey. Pure mathematics is the search for eternal structure and absolute beauty. Honestly, you can imagine pure mathematicians happily isolating themselves in some hyperbolic time chamber, needing literally nothing but a whiteboard and a fresh pot of coffee to prove absolute, infinite truths. It's noble work, but applied mathematicians? They take those pristine, elegant concepts and essentially drag them out into the messy, noisy real world to map and model our complex reality. Grounding this in everyday reality, just consider abstract number theory. A pure mathematician might literally spend decades studying prime numbers, doing it purely for the intellectual beauty of understanding the fabric of logic itself. But eventually, maybe years later, that exact same number theory becomes the applied math, specifically cryptography, that actively protects your family's bank account from being hacked when you're just out buying groceries. See, the pure logic ultimately becomes the applied shield. They rely on each other completely to function in our modern society. Moving one step down the continuum, we arrive at physics, and once again we see this really beautiful split. Pure physics asks, what are the fundamental laws of reality? The pure physicist is the one staring deep into quantum fields, dark matter, the very fabric of space-time itself. But the applied physicist? They look at that research and ask, okay, but can this principle become useful? They take those quantum laws and use them to build fiber optic networks, lasers, semiconductors, and MRI machines. They turn theoretical frameworks into life-changing functional innovations. Now, as we move further down the continuum, we officially leave those abstract roots and enter the physical, heavy-duty world of the builders. This is exactly where science turns into STEM. Engineering and technology are where we take everything the mathematicians and physicists so graciously discovered and we force it to work under extremely strict real-world constraints. Look, in the world of the builder, a brilliant idea is utterly useless if it's too dangerous or too expensive for society to actually use. We aren't just looking at physics anymore. We are looking at cost, manufacturability, and most importantly, human safety. Let's clarify a very common area of overlap and confusion. Engineering versus engineering technology. Engineering is heavily focused on design and analysis. Engineers conceptualize complex systems using advanced calculus, thermodynamics, and theoretical modeling. Engineering technology, on the other hand, is all about building, integrating, and troubleshooting. Technologists are the hands-on specialists. Think of it like this. If the engineer designs the suspension bridge on paper, The technologist is the one physically testing the materials and making absolutely sure that bridge doesn't wobble when a massive semi-truck guides over it. Briefly, let's look at the traditional ABUT accredited builder disciplines: mechanical, electrical, chemical, aerospace, and biomedical. This is the noble work of translating whiteboard theory into physical reality. These are the sharp minds that give us jet engines that cross oceans safely, power grids that light up our homes during a freezing winter storm, and biomedical prosthetics that restore a person's ability to walk. It is a profoundly impactful, absolutely essential career path for the betterment of society. But what if you just flat out refuse to choose between the whiteboard and the workbench? Well, let me introduce you to engineering physics. I really like to call this the source code of engineering. It's the ultimate hybrid path. It combines the rigorous, advanced, theoretical physics of a pure science major with the practical, relentless design and problem-solving skills of an engineer. It's for that rare student who wants to understand the absolute quantum root of the science, while still putting on safety goggles to go build the actual device. Let's read more into a fantastic piece of history to show you what I mean. The year 1995. This is the year Eric Cornell, who was an engineering physics graduate, synthesized the very first Bose-Einstein condensate, achieving temperatures incredibly close to absolute zero. And he won a Nobel Prize for this? But how did he do it? By expertly mixing the theoretical rigor of quantum physics with the experimental, hands-on ingenuity of an engineer. He had to actually design and physically build the intricate magnetic cooling apparatus that proved the theory. That is the true power of bridging the continuum. Alright, now let's pivot to a really crucial career crossroad, because at some point the technical continuum eventually intersects with the economic continuum. Welcome to the boardroom. This is the precise moment where highly skilled technical professionals must look in the mirror and make a tough decision. They have to decide if and exactly when they need to develop business acumen to scale up their ideas and take their impact to the next level. Let's map out this very common career progression. You typically start out as a technical contributor, where your math, design, and coding skills are quite literally all that matter. But as you transition to a project manager, and eventually perhaps even to a CEO, your raw technical skills become noticeably less important than your ability to manage resources, allocate budgets, and lead diverse teams. Consider leaders like Tim Cook at Apple or Satya Nadella at Microsoft. Both started with deeply technical engineering backgrounds, but they intentionally mapped serious business knowledge onto that foundation. Business fluency simply became a mandatory survival skill for scale. But look, that transition is rarely easy. Check out this quote. Instead of solving engineering problems, you have to solve people problems. You have to indulge in company politics. As an older brother giving you some earnest mentorship right now, I have to tell you the honest truth. Engineers often make absolutely fantastic CEOs because they naturally know how to systematically solve highly complex problems. But dealing with subjective office politics, navigating human emotions, and managing investor expectations, well, it isn't for everyone. It requires a completely different type of emotional energy and patience. So you might be wondering, why do business and STEM even need to mix at a macro level? Well, because venture-backed revenue accounts for a staggering 21% of the US GDP. That is a massive, landscape-shifting economic footprint. The technology startups that largely define a modern, fast-paced economy, they rely entirely on venture capitalists, business investors, funding brilliant STEM innovators. If these two sides don't understand each other, if they literally can't speak the same language, the great engine of innovation just stalls out entirely. And the hard data absolutely back this up. Research shows that venture capitalists genuinely must have technical competence. Look, when a VC has a strong technical background, their accuracy in evaluating a startup's true potential skyrockets, and the startup's failure rate plummets. You simply cannot properly or safely invest in a deeply technical solution, like a brand new AI architecture or a clean energy grid, if you don't actually understand the math or the code that's operating under the hood. I absolutely love this witty analogy from tech investor Mark Andreessen. He says, imagine going on a transatlantic voyage without a ship. Without software engineering knowledge, we will fare no better. It perfectly cements the idea, doesn't it? Trying to assess a sophisticated tech venture without underlying technical knowledge is an impossible, sinking task. The business world desperately needs people who can confidently and accurately speak the language of STEM. Now, to be completely fair and impartial here, we must balance the narrative. Business acumen is undeniably valuable, but is it always necessary? The answer to that is a resounding no. There is a deeply respected realm of the STEM continuum we call the deep specialists. For these highly rigorous, noble career paths, corporate networking and boardroom business skills are completely unnecessary to achieve true greatness. Think about pure mathematicians, deep kept lab physicists, or advanced cryptography experts. If you are a brilliant scientist synthesizing groundbreaking quantum materials in a university basement lab, or you're designing the complex encryption algorithms that keep national secrets safe, your only currency is absolute technical mastery. The math absolutely speaks for itself. You don't need to pitch to a boardroom, my friend. Your rigorous truth is your ultimate, undeniable value to the world. So, as we wrap up our cup of tea together, I really want to ask you one final question to reflect on. Where does your own mind naturally gravitate on this continuum? Are you the pure theorist, seeking out absolute truth? Are you the hands-on builder, designed for safety and function? Or are you the engineering CEO who wants to scale those solutions for millions of people? I sincerely urge you, please don't chase external prestige or what simply looks good on the internet. Reflect on your own mental identity and find the honorable path where your natural curiosity truly thrives. I want to leave you with this inspiring thought. Regardless of where you land on the continuum, the future increasingly rewards mathematical maturity, computational literacy, and systems thinking. So as you finish your tea and step back out into the world today, I leave you with this. Which part of the universe are you going to decode, and what are you going to build with it? Thank you for joining me in this explainer. Until next time, stay focused, stay honorable, and stay curious.